Now we are going to discuss about impact of jet on veins. First, I am going to tell about the main parts of this experiment. This experiment, the main part is what? The nozzle. In our lab, we have three different nozzles, 4 mm, 5 mm and the 6 mm nozzle. For our experiment, we are going to use 5 mm diameter nozzle, and this is the vein. We can fix the vein here. Vein is also three different veins are there in our lab. So this is hemispherical vein, depend upon their shape. And the next one is what? This is the flat vein. Here you can see the vein is what? The flat. Next, the vein is what? Inclined vein. Inclined vein. Now we will going to do the experiment on impact of jet on the hemispherical vein. Which vein we want, that vein we can fix it here. Later, the next part is what? The scale. This is the scale. Here, how much of the impact is from the jet of water over the vein can be noted down from this scale. First, we have to level this scale. Here you can see that the level is not there, so we should make that should be the proper level. Make that should be the proper. Next, make the scale to 0 reading just by rotate this knob to make to 0. So this is the initial setup of this experiment. And here is the pump is there. With the help of the valve, we can conduct the experiment for different readings. Here is the rotameter. First, we will going to conduct the experiment for 10 LPM, 20 LPM, 30 LPM, likewise different flow rate. What is the impact of jet? What is the impact of jet on the vein is to be calculated. Now we will going to start this experiment by switching the on. I already mentioned. First, make this vein should be low discharge. Especially while we are conducting this experiment, start the discharge from lower discharge to the higher discharge. Especially this experiment, don't go for the higher discharge to the lower discharge. Start from the lower discharge to the higher discharge. So make this valve closed on the pump. Just I will take the reading of one reading. Same thing will be do for the remaining flow rate also. Just I am going to on the pump. Here I am going to do the experiment for the 20 LPM. Set the rotameter to the flow of water at the 20 LPM and note down the reading. How much of the scale is get deflected. Initially it is 0. Now it is showing the 100 gram. 100 gram it is showing. Same wise, here you can see that the impact of water over the vein. The kinetic energy of the impact, the kinetic energy of the jet of water is to be impacted over the vein. That force will be taken from the scale. Here it is showing what? 100 grams. So this should be noted for the calculation. Similarly, different readings to be noted down. 20 LPM, 30 LPM as well as the 40 LPM. The next part is what? I am going to discuss about how to do the calculation. Okay, now we will going to continue the calculation part of impact of jet on veins. Just now we learn how to conduct the experiment on impact of jet on veins. Now come to the calculation part. First, the observation is you should take the diameter of the nozzle. So in our lab, we're going to use 5 mm diameter of the nozzle, 5 mm diameter of the nozzle. That should be converted to the meter, and calculate the corresponding area of the nozzle, pi d square by 4.
Then this is the tabular column. In the tabular column, three different veins are mentioned: flat vein, inclined vein, and spherical vein. Now just take this flat vein. First, the actual discharge that should be taken in LPM from the rotameter. 10 LPM, 20 LPM, 30 LPM, 40 LPM is there. For different flow rate, we should take the different readings. For example, you take 20 LPM, then that should be converted into the meter cube per second. The equation is to convert LPM to the meter cube per second is, here is the equation. What is the values that divided by 60,000, that will be converted to the meter cube per second. Next, the actual force. The actual force is what that should be taken from the scale. I'm going to show that one. See, this is the scale. This is the scale. From this one, you should note down the readings, and the LPM reading should be noted down from the rotameter. Only the two readings should be taken to calculate the calculation purpose. Next, that should be taken in grams, that should be converted into the kg, then that is converted into the Newton. That is by using this equation. Just you multiply by the 9.81 to convert kg force to the Newton. That is the next. Theoretical force is calculated by the formulas, and velocity of the jet can be found out by the this one, Q actual divided by area. Actual discharge is already taken from what? From the rotameter. Here Q actual is there. We know the area of the nozzle. Q actual by area, you will get the velocity. Here this is the what? Theoretical hydrodynamic force. This is the equation. Rho into area into velocity square. Rho is what? Density of the water. A is the area of the nozzle. V is the velocity that is obtained from here. So this is what theoretical value. Actual value I already mentioned, that should be noted down from the scale. Multiply by 9.85, you get the Newton. Then coefficient of impact is force actual divided by force theoretical. If you do this one, you get the coefficient of impact CI. So this is what about calculation for the flat vein. Next, come to the inclined vein. Everything will be the same thing. Only the theoretical force is different equation, because this is here is the inclined vein. So the equation is multiplied by sine square theta. Sine square theta, the remaining thing, everything is same. To find out actual discharge, velocity of the jet, the actual force is everything same, but theoretical force is what? Multiplied by sine square theta. Next, for the hemispherical vein, there also what? The formula will be different. We have to multiply by 2 into rho a v square. This is the actual force, sorry, theoretical force for the hemispherical vein. So this is about what? Calculation part of the impact of jet on veins. Only the two readings should be noted down. What is the flow rate and what is the force that is obtained in the scale.